Let's use some sum and difference identities. First of all, we want to find the exact value of the expression cosine of 15 degrees. We have to look at 15 degrees and consider it either a sum or difference of angles whose cosine or sine we know exact values for. One way you could get to 15 degrees is you could take 45 degrees and subtract 30 degrees. There's other options, but let's use that one. So if we want the cosine of 15 degrees, we can find the cosine of 45 degrees minus 30 degrees. Using a cosine difference identity, this is cosine 45 degrees times cosine 30 degrees plus the sine of 45 degrees times the sine of 30 degrees. Remember, the identity is cosine A minus B is cosine A cosine B plus sine A sine B. And now I put in exact values for these sines and cosines. The cosine of 45 degrees is exactly square root 2 over 2. The cosine of 30 degrees is exactly square root 3 over 2. The sine of 45 degrees is exactly the same as the cosine of 45 degrees, square root 2 over 2. The sine of 30 degrees is 1/2. Now simplifying each product, square root 2 times square root 3 is square root 6 over 2 times 2, which is 4. And I add that to the square root of 2 times 1, which is square root 2 over 4. Adding the numerators, because the fractions already have the same denominator, this is square root 6 plus square root 2 over 4. Well, let's try another. Let's, using radians this time, find the exact value of the cosine of 5 pi over 12. Well, the first thing we have to do is to take 5 pi over 12 and find it in terms of angles in radians, either a sum or a difference of angles in radians that we have sine and cosine exact values for. One combination is to consider it pi over 6 plus pi over 4. And that might seem a little bit arbitrary, but remember, in terms of something over 12, pi over 6 is 2 pi over 12, and pi over 4 is 3 pi over 12. 2 pi over 12 plus 3 pi over 12 is 5 pi over 12. So continuing, if I'm interested in finding the cosine of 5 pi over 12, I can find the cosine of pi over 6 plus pi over 4. And this is going to require the cosine sum identity. The cosine sum identity requires that we take the cosine of pi over 6 times the cosine of pi over 4 and subtract the sine of pi over 6 times the sine of pi over 4. The identity is cosine A plus B is cosine A cosine B minus sine A sine B. Now we're going to put in exact values. The cosine of pi over 6 is square root 3 over 2. Cosine pi over 4 is square root 2 over 2. Minus the sine of pi over 6, which is 1/2, times the sine of pi over 4, which is square root 2 over 2. And now we want to simplify. Square root 3 times square root 2 is square root 6. 2 times 2 is 4. Minus 1 times the square root of 2, which is square root 2, over 2 times 2, which is 4. The fractions have the same denominator, so we'll subtract the numerators, or write them subtracted in any case, and get the square root 6 minus the square root of 2 all over 4. Continuing, let's try one more example. Here we want to find the exact value of the expression cosine 87 degrees times cosine 93 degrees minus sine 87 degrees times sine 93 degrees. Well, I don't have an exact value for cosine 87, cosine 93, or either of these sines, but I see that I have cosine, cosine minus sine, sine. And the identity that I can match this to, or that this is the right-hand side for, is the cosine sum identity. The cosine sum identity, cosine A plus B, is cosine A cosine B minus sine A sine B. So if A is 87 degrees and B is 93 degrees, what I have matches this right-hand side. And so, working from right to left, what I have is exactly equal to the cosine of 87 degrees plus 93 degrees. Now, 87 plus 93 is 180 degrees, and the cosine of 180 degrees is -1, and that's the result.
Find one value of theta that satisfies the following. Cotangent theta is equal to tangent of 25 degrees. Now, since tangent and cotangent are cofunctions, we can rewrite the left-hand side as the tangent of 90 degrees minus theta. And of course, leave the right-hand side as is, so that's equal to tangent of 25. But now, if we have the tangent of an angle equals a tangent of another angle, that means we can say that the two angles must be equal. That is, 90 degrees minus theta equals 25 degrees. Solving for theta, we end up with theta is equal to 65 degrees. Let's work another example. Find one value of theta that satisfies the following. Sine of theta is equal to cosine of -30 degrees. Now, sine and cosine are cofunctions, so we can rewrite the sine of theta as cosine of 90 degrees minus theta, and that equals leaving the right side as is. But since we have the cosine of an angle equals the cosine of another angle, that means that this angle is equal to this angle. That is 90 degrees minus theta is equal to -30 degrees. Solving for theta, we find theta is equal to 120 degrees. Let's work another example. Find one value of x that satisfies the following. And we have cosecant of 3 pi divided by 4 is equal to the secant of x. Well, cosecant and secant are cofunctions, so we can rewrite the right-hand side in terms of cosecant, and so we would have, the left-hand side remains the same, cosecant of 3 pi divided by 4 is going to be equal to the cosecant of pi divided by 2 minus x. Well, we have the cosecant of an angle equals the cosecant of this angle, so this angle must be equal to this angle. That is 3 pi divided by 4 must be equal to pi divided by 2 minus x. Solving for x, we will end up with x is equal to negative pi divided by 4.
Let's use a cosine difference identity. We want to write the cosine of 180 degrees minus theta as a trigonometric function of theta alone. Well, the cosine difference identity applied to cosine 180 degrees minus theta requires that we find cosine 180 degrees times cosine theta and add the sine of 180 degrees times the sine of theta, applying the identity. Now the sine of 180 degrees is 0, and 0 times sine theta is going to be 0. The cosine of 180 degrees is -1, and -1 times cosine theta is negative cosine theta, and we've written cosine of 180 degrees minus theta in terms of theta alone. Let's work with a cosine sum identity. Suppose that sine of s is 3/5, cosine of t is -12/13, and both s and t are in quadrant 2. Find cosine of s plus t. Well, what I want to start with is sketching possible pictures that match the sine of s is 3/5 and cosine of t is -12/13. So for s, I need some angle. Here's the y-axis and here's the x-axis. and here's angle S, that ends up in quadrant 2, such that its sine, so if I take the opposite side over the hypotenuse, is 3/5. I want to find this adjacent side. Look at this triangle. This has to be a 3, 4, 5 right triangle, but because this side extends to the left, I'm going to label that side -4. So there's angle S, a picture that I could use. For angle T, I want to draw something similar. Here's X, here's Y. I need some angle that has its terminal side in quadrant 2. And I want the cosine, so I'm dropping a perpendicular here, of this angle to be -12/13. That makes the adjacent side -12 and the hypotenuse 13. And this is again a Pythagorean triple. If I have -12 and 13, this side must be 5. And you can check that out using the Pythagorean theorem. Now based on those pictures, I'm supposed to find the cosine of S plus T. So here's where an identity comes in. Cosine S plus T, a cosine sum identity, is cosine S times cosine T minus sine S times sine T. And for each trig function, I fill in a value. The cosine of S, here's angle S, is -4/5. The cosine of T is -12/13 minus the sine of S is 3/5. The sine of T is 5/13. Now let's simplify. -4 times -12 is 48. 5 times 13 is 65. Minus 3 times 5 is 15/65. And I can subtract the fractions since they have the same denominator to get 33/65. So based on these two pieces of information, the cosine of S plus T is 33/65. Let's work an application problem. Common household electric current is called alternating current because the current alternates direction within the wires. The voltage V in a typical 115 volt outlet can be expressed by the function V of t equals 163 sine omega t, where omega is the angular speed in radians per second of the rotating generator at the electrical plant, and t is time measured in seconds. Well, it's essential for electric generators to rotate at precisely 60 cycles per second, so household appliances and computers will function properly. We want to determine omega for these electric generators. Omega is to be measured in radians per second, so for 60 cycles per second, if 2 pi radians are available for each cycle, we multiply that times 60 cycles per second to end up with 120 pi radians per second as omega. And so we've found omega for these generators, which leads us to the formula 163 sine 120 pi t. So here's what we want to do with that V. What we want to do is graph V in the window 0 to 0.05 by -200 to 200. Well, we're going to do that with the help of a graphing calculator. So let's enter the function in y equals. We want to enter 163 sine of 120 pi times x, using x for the calculator's sake. As a window, we're directed to set 0 to 0.05, and we could set a scale of 0.01 in the x direction. That'll match that very nicely. Then -200 to 200 with a scale of 50 in the y direction. If we look at that graph, we get a graph of that particular voltage. We'll keep that in mind, and we want to go back and answer another question involving the same problem. We want to determine a value of phi so that the graph of V of t equals 163 cosine this time, not sine, but cosine of omega t minus phi is the same as the graph of v of t equals 163 sine omega t. Well, the phi that we're going to come up with is based on the fact that the cosine of x minus pi over 2, this is an identity, is equal to the sine of x. Now, both of these functions have period 2 pi, but pi over 2 is the value of phi that will allow us to match our sine and cosine as they are. So for phi, we're going to use pi over 2, and the voltage function we're looking for is 163 cosine omega t minus pi over 2.
Verify that the following equation is an identity. The secant of the quantity 3 pi divided by 2 minus x is equal to negative the cosecant of x. To do this, we're going to work with the left-hand side. So I've only written the left-hand side of this on the sheet of paper, and we'll make it work with it until we can get it to equal negative cosecant of x. So we begin by rewriting this in terms of cosine. So remember, secant of an angle is 1 over cosine of that angle. So this is going to be 1 over the cosine of 3 pi divided by 2 minus x. Then this is going to be equal to, we can use the cosine difference identity to write this as 1 over, first the cosine of 3 pi over 2 times the cosine of x, and then plus the sine of 3 pi over 2 times the sine of x. So let me extend that. So that's our new denominator. Now let's evaluate the cosine of 3 pi over 2. That's equal to 0. So we have 1 over 0 times the cosine of x plus, now evaluating the sine of 3 pi over 2, that's equal to negative 1. So I'll put that in parentheses, times the sine of x. Well, of course, 0 times anything is 0. 0 plus anything is just the anything. That is to say, we would have negative 1 times sine of x, which is negative sine x. So this is equal to 1 over negative sine of x. Our answer is going to be negative, and I'm going to extract that out at the beginning. And then 1 over sine x is cosecant of x. And now we've shown that that equation is an identity because we were supposed to show that secant of 3 pi over 2 minus x was equal to negative the cosecant of x, and we've done that.